So just in case you're wondering, on problems 15 through 20, it says you're supposed to verify. So I'm going to show you the verification for 15. We'll do 16 and verify. And then 17 through 20, don't worry about verifying. Okay? So to verify this one right here, that these are truly inverses of one another, I'll take g of g inverse of x. So that means I'm going to take this right here and I'm going to plug it right in there for where x is for the g. So that's going to equal 3 times x plus 5 over 3 minus 5. So the 3 simplify, giving me x plus 5 minus 5, which then gives me x, and I verified. We're done. Look right here. So let's find the inverse. So x equals 3y plus 7 all over 2. Go ahead and multiply by 2. It gives us 2x equals 3y plus 7. And subtract the 7. That gives us 2x minus 7 equals 3y. Divide everything by 3. And there's the inverse. F inverse of x is going to equal 2x minus 7 over 3. To verify, I'm going to take f of f inverse of x. In other words, I'm going to take this, plug it right in there for x. So I get 3 times 2x minus 7 over 3 plus 7 all over 2. So here the 3's are going to simplify. Then the negative 7's over plus 7 is going to cancel. It'll give me 2x over 2, which the 2's then will simplify, giving me just x. And we're done. Okay. On these ones over here, we're just going to find the inverse. We're not going to verify them, okay? So, find this guy's inverse. I have x equals 2 to the y plus 8 all over 4. So I tell you to first multiply by 4. So basically we're isolating this exponential here. So that gives us 4x equals 2 to the y plus 8 minus the 8. That's going to give us 2 to the y equals 4x minus 8. Now I'm going to take log base 2 of both sides. I get y equals log base 2 of 4x minus 8. Notice that 4x minus 8 is in parentheses because I did that before I took the log base 2. And you're done. Now number 18. Again, so we're going to have x equals 3 log base 2 of y plus 3 plus 3. Then we're going to subtract the 3 first. Gives us x minus 3 equals 3 log base 2 of y plus 3. Divide by 3 to get the log all by itself. Now that we have the log isolated, we're ready to eliminate. So I eliminate by taking 2 to the exponent. I take 2 to the exponent. That will simplify, so I get y plus 3 equals 2 to the x minus 3 over 3. Then I subtract 3, and there's my inverse right there. Done. Okay? Take a look at number 19. Now we have x equals y over y minus 4. Do you remember these? Multiply by y minus 4. So as I do that, I get xy minus 4x equals y. Get this y's on the same side, everything else on the other. So I'm going to subtract y, and I'm going to add 4x. So that gives me xy minus y equals 4x. Factor out the y. That gives me x minus 1 equals 4x. Divide by x minus 1. It's going to give me y equals 4x over x minus 1, and there's my inverse. So g inverse of x equals 4x over x minus 1. Done. 20. Here we go. So I get x equals 2y minus 1 over y plus 2. Multiply by y plus 2. Multiply by y plus 2. Giving me xy plus 2x is equal to 2y minus 1. I would subtract over the 2y. Subtract over the 2x to the other side. That gives me xy minus 2y equals, you could write it as negative 2x minus 1 or negative 1 minus 2x. Factor out the y. It's going to give me x minus 2 on the inside. Divide by the x minus 2. And right there's your inverse. And you're done. Okay, evaluate. So again, remember, we're trying to write 27 using the base of 3. Oh yeah, that's just 3 cubed. So log base 3 undoes 3 to the exponent. It leaves me with just 3. Done. We're trying to write 1 over 32 with the base of 2. Oh yeah, well 2 to the 5th is 32 and I want it to go down, so it's got to be 2 to the negative 5th. We'll simplify, leaving me just negative 5. Log base 10 of 1, I want to write 1 with the base of 10. Oh yeah, that's just 10 to the 0, so that's just 0. Here I want to rewrite 1/2 with the base of 1 over 16. Well, let's think about that for just a second. The 4th root of 16 is 2. So if I rewrite 1/2 as 1 over 16 to the 1/4 power. Remember, the power's on high, the root's on the bottom. So this is the 4th root of 16, which is 2. So the 4th root of 1/16 is 1/2. I get just 1/4. Done. Same thing here with 1/2, and I want it to become 1 over 16. Well, 2 to what power is 16? That's 4. So I can rewrite 1 over 16 as a base of 1/2 to the 4th. Log base 1/2 undoes, left with just 4. Take a look here. We're trying to write negative 3 with a base of 9. So you're trying to ask yourself, what could I take 9 to an exponent of and get negative 3? Well, the answer is absolutely nothing. This has no solution. Okay, log base 4 of 1/64. Can you write 1 over 64 as the base of 4? Hopefully so. First of all, to get the 4 to move down, it's got to be negative exponent. 4 to the power 64, that's 3. So my answer here is negative 3. Can you write 1 with the base of 12? Hopefully so. It's 12 to the, that's right, 0. That gives us 0. Oh look, it's already a base of 13. So log base 13 of 13 undoes, we get 5. E to the exponent of ln. Remember, ln has a base of e. We never write it, but it's there. So that just simplifies, leaves me with 25. To be able to do this problem, I have to have the same bases, which they do, log base 3, log base 3. I can bring them together then. Subtraction in logland is division. 6 divided by 2 is 3. So that's really log base 3 of 3, which is 3 to the 1. We never write the 1, but it's there. So that just leaves us with 1. So now, look, now they have different bases. They have different bases, so I can't bring them together. But log base 4 of 4, well, that will simplify to just 1. Can I rewrite 1/9 with a base of 3? And the answer is, oh yeah, I surely can. It's 3 to the negative 2. So those will undo, so then it's 1 plus a negative 2, which the answer then is negative 1. And we are done with that page. Moving on. Number 33. Now, take a look. I want to write 16 with the base of 2. So I get 16 is the same thing as 2 to the 4th, but then that's to the 3rd. Two ways you can do it. You can either bring the 3 down in front, okay, and make it 3 times log base 2 of 2 to the 4th, which then would just be 3 times 4, which is 12. Or our exponent rule now says I have a power to a power, which means I can multiply those. And this is the same thing as log base 2 of 2 to the 12th, which then just leaves me with 12. Either way, my answer is 12. Okay. Log base 4 of 8 plus log base 4 of 2. They're both log base 4, so go ahead and bring those together. 8 times 2 is 16. So that's log base 4 of 16. Can you write 16 with a base of 4? And the answer is yes. It is 4 squared. So the answer is 2. Take a look here. They both have log base 6. So I can bring them together. It's going to give me log base 6. Subtraction is division. Oh, before you can do that, stop. Stop. You got to get rid of this 3 right here. That sounds like a full class ticket. So you need to bring that 3 up. That's got to be 2 to the 3rd, which is 8. So therefore, we should get log base 6 of 48 over 8. And 48 over 8 divides into just 6, which therefore leaves us with 1. Remember, there's a 1 right here. We never write it, but it's always right there. Okay, 36. We are flying, folks. Expand. That means we want to go from one log into multiple logs. So I have multiplication going on. So multiplication in logland is, that's right, addition. There it is. Now we do want you to bring these exponents down in front. So that's going to give us log of 3 plus 2 log of x plus 3 log of y, and you're done. There's the answer. Here I have the natural log of division, so that's going to be subtraction. So I take the natural log of 2 minus the natural log of x to the k. The k, though, gets to come down in front, so that's going to be natural log of 2 minus k, natural log of x. We're done. Now they want us to do again. I have multiplication going on here between the 15 and a squared, the b cubed, and the c to the 4th. So it's log base 7 of 15 plus log base 7 of a squared plus log base 7 of b cubed plus log base 7 of c to the 4th. Bring down the exponents. So I get log base 7 of 15 plus 2 log base 7 of a plus 3 log base 7 of b plus 4 log base 7 of c. And done. Now, if I were you, personally, I would take this exponent d right here. I'd bring it down in front first. So that gives me d times log base a of b over c. Now I turn division into subtraction. So I have d times log of a b minus log base a of c. And you're done. You could distribute the d in. That would be okay. So it's the same thing as d times log base a of b minus d log base a of c. It all works. Here we go, 40. Now they want us to go the other direction. So they want us to bring all these logs together. And they're all log base 2, so that's okay. So we write it as 1 log base 2. Now, subtraction is division. Addition is multiplication. We're not multiplying these two. We're dividing 5 over 4. So it'd be like this. 5 over 4 times 8, which is like 8 over 1, which then gives me log base 2 of 5 times 8 is 40. 4 times 1 is 4. So really it's just log base 2 of 10. Okay? All right, 41. Before I can bring them together, I got to get the 2 up, and I need to get the 5 up. So I'm going to get the ln of x squared plus the ln of y to the 5th. The ln's are the same bases. They come together. Addition is multiplication. So it'd be x squared y to the 5th. Done. Here we go. Right here. Got to get that 5 up before I can do anything. So I have log of 12 minus log of x to the 5th. Now the log are the same bases. I bring it down into 1 log. Subtraction is division. 12 over x to the 5th. Done. Okay, I got to bring the a up. I got to bring the 4 up. So I write it as log base b of c to the a plus log base b of d minus log base b of e to the 4th. So now addition is multiplication. Log base b c to the a times d. Subtraction is division divided by e to the 4th. And there you go. Done, done, done. It says, write the value of the following expression. Look to the right for the values to use. Well, so first of all, just take these and expand them. Sorry, get it up here. Take these and expand them. So give us the ln of a plus the ln of b cubed minus the ln of c, which is really the ln of a plus 3 times the ln of b minus the ln of c. Now you'll notice ln of a is 2. So this is 2 plus 3 times the ln of b. ln of b is 3 minus the ln of c is 5. 3 times 3 is 9 plus 2 is 11 minus 5 is 6. The answer is 6. Okay, right here. So I would write this as the ln of b to the 1/6. I would bring the 1/6 down in front. Remember, the root goes in the below, the power goes on high. So that really gives me 1/6 ln of b. Again, ln of b is 3. So this equals 1/6 times 3, which is 3 over 1, which is 3 over 6, which is really just 1/2. Done! ln of a times b times the ln of c. Well, so this can be written as the ln of a plus the ln of b times the ln of c. Well, the ln of c is 5. The ln of a is 2. The ln of b is 3. 2 plus 3 is 5 times 5 is 25. Done! Dun, dun, dun! Multiplication is addition. The ln of d plus the ln of a to the 1/2. Bring the 1/2 down in front. ln of d plus 1/2. ln of a. ln of d is 7 plus 1/2. ln of a. ln of a is 2. 1/2 of 2 is 1. 7 plus 1 is 8. Dun, dun, dun! We're so close. ln of 1 over b to the 4th. Really, that's the same thing as ln of b to the -4. Bring the -4 down in front. -4 times the ln of b, which is -4 times 3, which is -12. It says, what are the exact values of a? If I want to find a, I want to undo ln, so I take e to the exponent. So a equals e squared. If I want to find b, I take e to the exponent. So b equals e to the 3rd. That means c would equal e to the 5th, and d would equal e to the 7th. Done! Woo! Folks, I know it's long, but just stick with me. We're almost there. It says, how's the graph of the logarithmic function log base 4 of x related to the graph of the exponential function g of x equals 4 to the x? Well, this is a base of 4. This is a base of 4. These are inverses of each other. And if they're inverses, then that means the domain of f of x will be the range of g of x. And the range of f of x will be the domain of g of x. And intercepts, remember, with the log, we have the point 1, 0, which means for the inverse, which is an exponential, we'll have the point 0, 1. And with an asymptote, we have x equals 0. And here we'll have the asymptote y equals 0. Our end behaviors will just switch. So here on the log, the end behavior says as x approaches 0, f of x approaches negative infinity. And as x approaches infinity, f of x approaches infinity. Where over here we're going to say as x approaches negative infinity, g of x approaches 0, and as x approaches infinity, g of x is also going to approach then infinity. Okay, I'm going to stop it here, and then we'll do the rest. Hold on 1 second, and we'll be right there. Okay, what do you got?
Finished? I just wonder what time you'll be here tomorrow morning, because I was supposed to come in this morning.
Yeah.
That was on me.
So tomorrow I'll be, it's okay, tomorrow I'll be here at 7:15.
Perfect.
Does that give you enough time, you think?
Yeah, I've been reading through the textbook, and I've Googled some stuff because I did not listen to your class, and that's my fault. But definitely going to learn everything tonight, and so just a few more practice problems in the morning would be helpful.
Okay.
Fantastic. Thank you.
You betcha.